Good day, everybody. How are you all doing? Today we will talk about sampling. So I'll share my computer screen with you. So we'll start from the beginning of this. So let me go back. So we are going to describe the investigative process of statistics. We will construct a simple random sample. We will determine when samples of convenience are acceptable. We will describe stratified sampling, cluster sampling, systematic sampling, and voluntary response sampling. We will distinguish between statistics and parameters. So first we will describe the investigative process of statistics. In the months leading up to an election, of the polls often tell the percentage of voters that prefer each candidate. Polling follows a process that is typical in statistics. So, what is statistics? It's an investigative process. That means we conduct an investigation or a search that involves these steps. First, we will formulate the questions we want to answer. Then we will collect data needed to answer those questions. Then we will describe the data or the information that we have gathered, and we will draw conclusions using appropriate methods. So here are some of the terms, involved terms. What the first one is statistics, is the study of procedures for collecting, describing, and drawing conclusions from information. So first we'll collect information and then we'll describe the characteristics of the information and then we'll draw conclusions from the information that we have gathered. What is a population? Is the entire collection of individuals about which information is sought, such as all the students at a college registered in spring semester, the entire collection of all students. And what is sample then? It's a subset or part of a population containing the individuals that are actually observed. Why do you work with a sample? Because population is too large. We cannot reach the population all the time. Therefore, we work with a sample, which is a part or subset of the population. Ideally, we would like our sample to represent the population as closely as possible. Unfortunately, there are no methods that can guarantee this. Okay. The best sampling methods all involve random selection. Random means without any order, without any preference. The most basic and in many cases the best sampling method is the method of simple random sampling. A simple random sample of size n is a sample size, is a sample chosen by a method in which each collection of n population items is equally likely to make up the sample. What do they mean by this definition? Here is the example. A simple random sample is analogous to a lottery. Suppose that 10,000 lottery tickets are sold and 5 are drawn as winning tickets. Each collection of 5 tickets that can be formed is equally likely to comprise the group of 5 that is drawn. What they mean is that there are many, many samples of size 5 that can be drawn from this population of 10,000 lottery tickets. And each collection of those 5 tickets, if they have an equal chance of getting selected, then they make up a simple random sample because every group of 5 tickets has an equal chance of getting selected. A physical education professor wants to study the physical fitness level of 20,000 students enrolled at a university. She obtains a list of 20,000 students numbered from 1 to 20,000. How are they numbered? Maybe based on their last name alphabetically, and uses a computer random number generator to generate 100 integers between 1 and 20,000. Remember, the students are listed from 1 to 20,000. They're numbered from 1 to 20,000. Then we use a computer to generate a random list of 100 numbers between 1 and 20,000. So there will be a list of 100 numbers. Then we will select those students with those 100 numbers, invite the 100 students corresponding to those numbers to participate in the study. Is this a simple random sample? Yes, this is a simple random sample, since any group of 100 students would have been equally likely to have been chosen. Every time you ask the computer to generate a list of 100 numbers between 1 and 20,000, it will be a fresh list. So any group of students, 100 students generated by the list from the computer, has an equal chance of getting selected. Therefore, this is a simple random sample consisting of any group of 100 students who have an equally likely chance to get selected. The professor in the last example now wants to draw a sample of 50 students to fill out a questionnaire about which sports they play. The professor's 10 a.m. class has 50 students. She uses the first 20 minutes of the class to have the students fill out a questionnaire. Is this a simple random sample? No. A simple random sample is like a lottery in which each student in the population has an equal chance to be part of the sample. This sample does not meet the criteria because only students in the class are selected. The students outside the class are not selected. Therefore, this is not a simple random sample. A pollster wants to estimate the proportion of voters in certain towns who are Democrats. He goes to a large shopping mall and approaches people to ask whether they're Democrats. Is this a simple random sample? No. This sample consists of only people in the town who visit the mall. Okay? There are people who do not visit the mall. Therefore, this is not a simple random sample. A telephone company wants to estimate the proportion of customers who are satisfied with their service. They use a computer to generate a list of random phone numbers and call those people to ask them whether they are satisfied. Is this a simple random sample? Yes, every group of n customers where n is a simple sample size is equally likely to be chosen. The reason is because the computer is used to generate a list of random phone numbers. And every sample of size n has an equal chance of getting selected. So this is a simple random sample. Determine when samples of convenience are acceptable. In some cases, it is difficult or impossible to draw a sample in a truly random way. In these cases, the best one can do is to sample items by some convenient method. A sample of convenience is a sample that is not drawn by a well-defined random method. So here is an example. Construction engineer has just received a shipment of 1,000 concrete blocks delivered in a large pile layers, okay? The engineer wishes to investigate the crushing strength by measuring the strengths in a sample of 10 blocks. Explain why it might be difficult to draw a simple random sample of blocks. Solution: to draw a simple random sample would require removing blocks from the center and bottom of the pile. That would be difficult because these are heavy blocks. So one way to draw a simple sample of convenience would be to simply take 10 blocks of the top of the pile. And again, the reason being the blocks that are on the top, easy to remove and select 10 of them for study. So if the cement blocks are all manufactured in the same way, the sample of convenience can give us good estimate of the properties of the population. The problem with samples of convenience is that they may differ systematically in some way from the population. If it is reasonable to believe that no important systematic difference exists, then it is acceptable to treat the sample of convenience as if it were a simple random sample. Describes stratified sampling, cluster sampling, systematic sampling, and voluntary response sampling. In stratified random sampling, the population is divided up into groups called strata. Then a simple random sample is drawn from each stratum. So strata is the plural of the word stratum, which means groups. Group. Stratum means group, strata means groups. Stratified sampling is useful when the strata differ from one another, but the individuals within a strata tend to be alike. So here is an example. A company has 800 full-time and 200 part-time employees. So 800 plus 200 is 1,000. To draw a sample of 100 employees, so you're going to draw a sample of 100 employees out of the 1,000 employees, out of which 800 are full-time and 200 are part-time. So we select a simple random sample of 80 full-time employees is selected, and a simple random sample of 20 part-time employees is selected. So first-time employees were divided into two strata. One is full-time employee, other is part-time employee. We selected a simple random sample of 80 full-time employees, and we selected a simple random sample of 20 part-time employees to make up the stratified random sample of 100. The strata are the groups of employees based on whether they're full-time or part-time. In cluster sampling, items are drawn from population in groups or clusters at random. Cluster sampling is useful when the population is too large and spread out for simple random sampling to be used. Cluster sampling, cluster also means groups. So what is the difference? To estimate the unemployment rate, a government agency draws a simple random sample of households in a country. Someone visits each household and asks how many adults live in the household and how many of them are unemployed. What are the clusters? Why is this a cluster sampling? The rectangular blocks on the left are the total number of households in the county. There are 11 households. Notice from those 11 households, a simple random sample of 5 households are chosen in the rectangular block in the center. Random sample of households is taken. The clusters are groups of adults in each household of the county. There are 11 households on the left, from which a simple random sample of 5 strata or 5 households are chosen. This is a cluster sampling because a simple random sample of clusters is selected, 5 out of 11, and every individual in each selected cluster is part of that sample. So we have cluster sample of individuals. Interview every individual in that household, in each household. Systematic sampling. In systematic sampling, items are ordered and every kth item is chosen to be included in the sample. Systematic sampling is sometimes used to sample products as they come off an assembly line in order to check that they meet quality standards. So here is an example. Automobiles are coming off an assembly line. A systematic sampling will be drawn for detailed check. The starting point will be third car. Question may be why starting at third? You could have started at position 2. Then every fifth car. So you start at position 3 and every fifth car after that. So which cars will be sampled? So third car, then 3 plus 5 is eighth car, 8 plus 5 is 13th car, 13 plus 5 is 18th car, and so forth. So this is a systematic sampling process. Comparison of the sampling methods. So on the left, you have simple random sample. You have people in different colors, individual, different color uniform, and simple random sample means selecting a simple random sample out of the total population of 36. So 12 individuals are randomly picked on the top left, simple random sample. There is no preference, no order. Okay. Systematic sampling. Systematic sampling, here you start at position 2 and then every third one after that. So second one person is selected, so second plus 3 is fifth, fifth plus 3 is eighth, and so forth. So that's systematic sampling. Top right. Bottom left, stratified sampling. You divide the population into strata based on the color of the uniforms, and then you selected simple random sample from each strata. So it is stratified sampling. What is cluster sampling? You divide population into groups based on the uniform colors. Here, as can be seen, you only work with two colors out of the six colors possible. So you select two colors and then talk with every individual in those selected strata. I mean, selected cluster. So this is a cluster sample. Stratified is on the left bottom, cluster sampling is on the bottom right. There's a difference in cluster sampling. Only two clusters are selected and everyone in the selected clusters is interviewed. Voluntary response samples are often used by media to engage the audience. For example, a radio announcer will invite people to call the stations to say what they think. Voluntary response samples are never reliable for the following reasons. People who volunteer an opinion tend to have stronger opinions that is typical of the population. People with negative opinions are more likely to volunteer their response. So voluntary response samples are not good because you are collecting information from people who are strongly against or strongly for the cause. So you're not catching the opinion of the people who are in the middle. A radio talk show invites listeners to send an email to express their opinions on an upcoming election. More than 10,000 emails are received. What kind of sample is this? Voluntary response sample, because only people who are interested will send out emails. Every 10 years, the US Census Bureau attempts to count every person in the United States. To check the accuracy of their count in a certain city, they draw a sample of census districts and recount everyone in the sample districts. What kind of sample is formed by the people who are recounted? So, you are dividing the city into clusters of census districts, and then only a couple of them are selected. Um, those clusters out of all the clusters possible. So this is a cluster sample. Everybody in the selected clusters are interviewed. So this is a cluster sampling. Our researchers designed the study the effect of diet on heart disease. The researchers know that diets of men and women tend to differ and that men are more susceptible to heart disease. To be sure that both men and women are well represented, the study comprises a simple random sample of 100 men and another simple random sample of 100 women. What kind of sample these 200 people represent? So remember, initially you are dividing in the population into strata, two strata. One is men, another is women. And then he was randomly selecting 100 people, 100 from men and 100 from women. So this is stratified sample as opposed to cluster sampling. A college basketball team held a promotion at one of its games in which every 20th person who entered the arena won a free basketball. What kind of sample do winners represent? Of course, this is a systematic sample. Okay. Distinguish between statistics and parameter. Statistic begins with letter S, is a characteristic of a sample, number that describes a sample. Parameter begins with letter P, is a number that describes a population. Which of the following is a statistic and which is a parameter? 57% of teachers. So all the teachers, it came Central High, out of them, 57% are female. So this is a characteristic of the population of teachers. So this is a parameter. The quantity 57% is a parameter because it describes the entire population of teachers in the school. In a sample of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief. So you have a sample size of 100, and out of those 100 patients, only 78% reported significant pain relief. Therefore, 78% is a sample characteristic, is a statistic. So this is all we discussed today: investigative process of statistics, difference between a population and a sample, what is a simple random sample, when samples of convenience are acceptable, differences among stratified sample, cluster sample, systematic sampling, voluntary response sampling. And then we discussed, lastly, the difference between a statistic and a parameter. I will stop here today. If you have any question, comment, please write me a comment. Please do not forget to write me a comment. I'll respond to all of your comments. And if you like this video, please give me a thumbs up. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. I will be back tomorrow. Please do not forget to watch me tomorrow with another interesting topic. Thanks for watching. Take care. Have a nice day. See you.